In the present video, we will discuss the example problem on unbalanced transportation problem solved by northwest corner rule method. Let's see the problem. Solve the following transportation problem. Here given the three supply centers P, Q, R along with respected supply and four demand centers A, B, C, D along with its respected demand. Let's see the solution. First, to check the given transportation problem is balanced or unbalanced. For this, check the total supply and total demand. So here total supply is the 100 plus 30 plus 70 equal to the 200 and total demand equal to the 40 plus 20 plus 60 plus 30 equal to the 150. So total supply is 200, total demand is 150. So total supply is not equal to the total demand. So given transportation problem is a unbalanced transportation problem. Moreover, in this problem, total supply is greater than the total demand. Now we have to convert the unbalanced transportation problem into balanced transportation problem. So here total supply is greater than the total demand. So add a dummy column with cost is 0 and dummy column demand equal to the total supply minus total demand. Here total supply is the 200, total demand is the 150. So dummy column demand is the 50. So now we have to modify the given transportation problem by adding a dummy column E. So we have to add the dummy column E with cost is 0 and its demand is the 50. So now once again I have to check the total supply and total demand. Total supply equal to the 100 plus 30 plus 70, 200. Total demand equal to the 40 plus 20 plus 60 plus 30 plus 50 equal to the 200. So total supply equal to the total demand. And now given transportation problem is a balanced transportation problem. Next, apply the northwest corner rule method to find the initial basic feasible solution. So this method is start with the northwest corner of the transportation matrix. So this is the northwest corner, that is the upper left corner of the transportation matrix. Here we have to allocate the maximum possible allocation, which means minimum of the demand or supply. Here demand is the 40 and supply is the 100. Among these two, minimum is the 40. So allocate the 40 in this cell and subtract the 40 in the demand and supply. That is 100 minus 40 equal to the 60 is the supply and 40 minus 40 is the demand. Now we have to remove the column A because its demand is 0. Next, select the northwest corner of the transportation matrix. Here, this is the northwest corner of the transportation matrix. Here, allocate the maximum possible allocation, which means minimum of demand or supply. Here, demand is the 20 and supply is the 60. So among the 20 and 60, minimum is the 20. So allocate the 20 in this cell. Next, subtract this 20 in the supply as well as the demand. That is supply will become the 60 minus 20 equal to the 40, and demand will become 20 minus 20 equal to the 0. Next we have to remove the column B because its demand is 0. Next to select the northwest corner of the transportation matrix. Here this is the northwest corner of the transportation matrix. Here we have to allocate the minimum amount of the demand and supply. Here demand is the 60 and supply is the 40. Among these two, minimum is the 40. So next subtract the 40 in the supply as well as the demand. So supply will become the 40 minus 40 equal to the 0. Demand will become the 60 minus 40 equal to the 20. So now we have to remove the row P because its supply is the 0. Next to select the northwest corner of the transportation matrix. So this is the northwest corner of the matrix. Here we have to allocate the minimum of the supply as well as the demand. Here supply is the 30 and demand is the 20. Among these two, minimum is the demand 20. So allocate the 20 here and subtract the 20 in the supply as well as the demand. So now demand will become the 20 minus 20 is the 0. Supply will become the 30 minus 20 equal to the 10. So now remove the column C because its demand is 0. Next to select the northwest corner of the transportation matrix. This is the northwest corner of the matrix. And here we have to allocate the minimum of the demand as well as the supply. Here supply is the 10 and demand is the 30. So minimum is the 10. So allocate the 10 here and subtract the 10 in the supply as well as the demand. Then supply will become the 10 minus 10 equal to the 0 and demand is the 30 minus 10 equal to the 20. Now we have to remove the row Q because its supply is 0. So next we have to select the northwest corner of the transportation matrix. So this is the northwest corner of the transportation matrix. Here I have to allocate the minimum of the supply and demand. Here supply is the 70 and demand is the 20. Among these two, minimum value is the 20. So allocate the 20 here and subtract the 20 in the supply as well as the demand. Now supply will become the 70 minus 20 equal to the 50 and demand will become the 20 minus 20 equal to the 0. Now we have to remove the column D because its demand is 0. So next we are having the only one cell. So here demand as well as the supply both are equal, that is the 50. Then allocate the 50 here and the subtract the 50 in the supply as well as the demand, both are will become the 0. So we completed the allocations up to the last cell, that is the southeast corner of the transportation matrix. Then write down the transportation matrix with the allocations is the initial basic feasible solution. So this is the initial transportation matrix along with the allocations. So this is the initial basic feasible solution, and here number of allocations are the 1, 2, 3, 4, 5, 6 and 7. So number of allocations are the 7, which is equal to the m plus n minus 1. Here m equal to the number of rows and n equal to the number of columns. So number of rows are the PQR, that is the 3, and the number of columns are the A, B, C, D, E, that is the 5. So m equal to the 3, n equal to the 5. So 3 plus 5 minus 1 equal to the 7. So number of allocations are equal to the m plus n minus 1, and moreover these all allocations are in the independent positions. So we got the non-degenerate solution. And transportation cost will become the 40 into 40 plus 25 into 20 plus 22 into 40 plus 30 into 20 plus 30 into 10 plus 30 into 20 plus 0 into 50. So total transportation cost is the 4,480 rupees. So this is the solution, and thank you.